I am Umayma Hamdi, a final year engineering student and a beta Microsoft Learn student ambassador. This session will be held by me and my friend Monica. I will let Monica introduce herself. So, Monica, please introduce yourself.
Yeah, thank you so much. So, good evening, everyone. My name is Monica. To those of you who are not familiar with me, I am a Beta Microsoft Learn Student Ambassador, and I'm also approaching to begin my final year. I'm an IT student, and yeah, Omayoma is not just my friend; she's my mentor, and I'm so excited to have this session with you guys. So, and I believe at the end of this, you guys will have learned something and would be excited with the session that we are going to be having. Thank you.
Uh, so, uh, Thank you, Monica. Uh, as you see here, the plan of our session will be as following. We will start by the definition of deep learning, neural networks, how deep learning works, deep learning techniques. We will see together some deep learning frameworks. We will see also CNNs or convolutional neural networks, and finally we will answer your questions. And if you have questions or suggestions, or so, we will begin by defining deep learning. So, deep learning is a subset of machine learning, which is essentially a neural network with three or more layers. These neural networks attempt to simulate the behavior of the human brain. For who doesn't know what are neural networks, so a neural network is a type of machine learning algorithm that is modeled after the structure and function of the human brain. It is a network of interconnected nodes or neurons which process and transmit information throughout a series of layers. Each layer is composed of interconnected neurons, or we can say nodes. As you can see in this slide, and as I said before, neural networks are a type of machine learning that is modeled after the structure and function of the human brain. In the picture below, you can see that this neural network is composed of three layers: an input layer, hidden layer, and output layer. The question now is what is input layer? What is its function? What is hidden layer? And what is output layer? So we will starting by input layer. So the input layer is the layer that accepts the data and pass it to the rest of the network. As we see in the previous slide, the input layer will receive the data and pass it to the hidden layer. So for the hidden layer, it's hidden layers are either one or more. In our network in the previous slide, we have one hidden layer, but we can in another network we can have one or more uh, hidden layers. So hidden layers are the ones that are actually responsible for the excellent performance and complexity of neural networks. They perform multiple functions. The number of hidden layers may vary from one to a high number of layers. So for the output layer, it holds the results of the output of the problem. We have also some layers. The input, the hidden layer, and the output layer are called basic layers. We have also specialized layers that can be used in neural network. I will list some of them. For example, we have convolutional layers that are commonly used in image processing, computer vision tasks. They apply a set of learnable filters to the input data to extract features. We have also recurrent layers. These layers are used for processing sequential data, such as natural language or time series data. They allow information to be passed between time steps or words in a sequence. We have also pooling layers. They are used to downsample the output of a convolutional layer, reducing the spatial dimensions of the future map. As we see here, we have multiple neural networks. Each neural networks have its function and uh, its characteristics, and it depends on the use case. The choice of the network we will use depends on the use case, its use case. Moving now to see the difference between deep learning and machine learning. So, deep learning and machine learning are both types of artificial intelligence that allow computers to learn without being explicitly programmed. However, there are some key differences between the two. Machine learning is a broad term that encompasses any type of AI that can learn from the data. This can include simple algorithms that can learn to make predictions based on a set of input data, or more complex algorithms that can learn to perform tasks like image recognition or natural language processing. Deep learning is a subset of machine learning that uses artificial neural networks to learn from the data. Artificial neural networks are inspired by the human brain, and they are able to learn complex patterns from data that would be difficult or impossible for traditional machine learning algorithms. Here we see that deep learning is has more benefits than machine learning when the data is too complex. Machine learning algorithms leverage structured and labeled data to make prediction. But this doesn't necessarily mean that it doesn't use unstructured data. It just means that if it does, it generally goes throughout some pre-processing to organize it into a structured format. In conclusion, machine learning used both structured and unstructured data. But if the data is structured, it there would be pre-processing before using the data. However, deep learning eliminates some of data pre-processing that is typically involved with machine learning. These algorithms can ingest and process unstructured data, like text and images. For example, let's say that we had a set of photos of different pets, and we wanted to categorize by cat, dog, hamster, for example. Deep learning algorithms can determine which features Let's see, for example, let's say ears. The ears of the animal are most important to distinguish each animal from another. Deep learning algorithms can determine the future by itself, but in machine learning, futures, the hierarchy of futures is established manually by a human expert. Uh, to understand the beta, machine learning in machine learning, the extraction of futures or of the important variables that we have to use in our model in our model are determined by a human expert, but in deep learning they are determined automatically by the algorithm. Moving now to see together how deep learning works. So deep learning neural networks, we can call them artificial neural networks also, attempts to mimic the human brain throughout a combination of data inputs, weights, and base. These elements work together to accurately classify and describe objects within the data. So, uh, deep neural networks, or DNN, consist of multiple layers of interconnected nodes, as we see in the beginning of the session, each building upon the previous layer to optimize the prediction or categorization. This progression of computations throughout the network is called forward propagation. The input and output layers of DNN are called visible layers, and the layers between the input and the output layers are called hidden layers, as we see before. The input layer is where the deep learning model ingests the data for preprocessing, and the output layer is where the final prediction or classification is made. There are also another process called backpropagation. This algorithm is used to calculate errors in prediction and then adjust the weights and biases of the function by moving backwards throughout the layers in an effort to train the model. The objective of backpropagation is to optimize the optimize the prediction and to improve the performance of the model. For the applications of deep learning, we have multiple application. For example, we have law enforcement, as deep learning algorithms can analyze and learn from transactional data to identify dangerous patterns that might affect society. We have also financial services, as financial institutions regularly use predictive analytics to drive algorithmic trading of stocks, assess business risks for loan approvals, detect fraud, and help manage credits. We have also customer service, as many organizations incorporate deep learning technology into their customer service process. For example, chatbots that are used in a variety of applications, services, and customer service portals. We have also healthcare, as the healthcare industry has benefited greatly from deep learning capabilities ever since the digitization of hospital records and images. Image recognition applications can support medical imaging specialists and helping them analyze and assess more images in less time. We have several deep learning techniques. Uh, First of all, we have convolutional neural network or CNNs that are commonly used for image and video processing tasks, as they are able to extract meaningful features from raw pixel data. CNNs use convolutional layer to learn filters that detect local patterns and edges, and pooling layer to reduce the dimensions of the future maps. We have also recurrent neural networks that are used for processing sequential data, such as natural language or time series data. RNNs use recurrent layers to allow information to be passed between time steps or words in a sequence, allowing the network to capture temporal dependencies. We have also general adversarial networks or GANs that are used for generating new data that is similar to a given data set. A GAN is a network that where its output is the same as its input. Uh, GANs use two neural networks, a generator network that creates new samples, and a discriminator network that tries to distinguish between real and generated samples. Or, as we can say, that distinguish between input and output data. The output data is the generated one, and the input data is the real one. The two networks are trained together in an adversarial way, with the generator trying to create samples that fool the discriminator. We have also autoencoders that are used for unsupervised learning and data compression. Unsupervised learning is a type of learning when we use unlabeled data. Autoencoders use an encoder network to compress the input data into a lower dimension representation, and a decoder network to reconstruct the original input from the compressed representation. There is a network which consists of two networks that are an encoder network and a decoder network. By training the network to minimize the reconstruction error, the encoder learns a compressed representation that captures the most important features of the input data. And finally, we have deep reinforcement learning, which are used for training agents to perform specific tasks in an environment by using rewards and punishment to guide the agent's behavior. Deep reinforcement learning combines deep neural networks with reinforcement learning algorithms to learn policies that maximize the agent rewards over time. So, to work with deep learning algorithms, we need frameworks, and Python have plenty of frameworks for this objective. So we will see together some of them. One of the most popular library or framework that is used for deep learning is PyTorch. I think that most of you know this library. So PyTorch is a Python package that provides two high-level features: tensor computation with strong GPU acceleration and deep neural networks built on tape-based autograde system. We have also TensorFlow, which is an open source software library for numerical computation using data flow graphs. We have MXNet, which is a deep learning framework too, designed for both efficiency and flexibility. It allows you to mix the flavors of symbolic programming and imperative programming to maximize productivity. We have MATLAB that makes deep learning easy for engineers, scientists, and domain experts with tools and functions for managing and labeling large data sets. We have JAX, which is a Python library designed for high performance numerical computing and machine learning research. JAX can automatically differentiate native Python and implement the NumPy API. We have uh, plenty of frameworks, but I list the most popular ones. You can search for the other frameworks. So the objective of this framework is to facilitate the implementation of deep neural network and to facilitate uh, and improve the performance of training and testing neural network. Now we will carry on with Monica. She will give you details about CNNs. If you have questions, as we say at the beginning of the session, we will answer them questions by question in the end of this presentation. So I hope that you understand the first part. And now I will let you with Monica to carry on with part two.
Okay, thank you so much, Omaima. And from what she has explained, I hope you guys have at least a beginner understanding of deep learning. She has even tried to give you a comparison between deep learning and machine learning, and for you to see how deep learning actually works and the frameworks in deep learning. Then from there, I'll be taking on convolutional neural networks. So she actually mentioned CNNs, though we're only covering CNNs here, but there are other, she mentioned some of, let me just go back for you to see. So she mentioned the other techniques in deep learning, but for this session, I'm only going to be covering CNNs. It's broad, we can't cover all the techniques deeply. So we'll just go over CNNs, but from there, you guys, if you can get a chance, you can go over the other techniques and actually read about them. So yeah, so I'll be taking you guys over CNNs. So CNN in full is convolutional neural networks, but I'll be saying CNNs. So if I say CNN, you'll actually know what I'm talking about. So to begin with, what is a CNN or a convolutional neural network? So just an overview, a CNN is I'll say an artificial neural network that has so far actually been used for analyzing images. So CNNs have commonly been used for image analysis. So that's what they're actually commonly used for, but it's not specifically its only function. There are so many other functions that are being used in CNNs. Like we have it's using data analysis, it's using classifications, and there are other applications which we'll get to have to see. But commonly just know that CNNs are used in analyzing images. So think of CNN as an artificial neural network that has a specialized ability to give you and detect patterns in images. So given that it's used to analyze images, so think of it as an AI that an artificial neural network that is able to actually analyze images and actually get to detect patterns in images. So that's why it's used in image analysis. So that's just an overview of what CNNs are. So CNNs are used in image analysis, and so they are actually able to detect patterns in images and actually make a sense out of them. So CNNs actually have layers. So we have convolutional layers, but there are actually other layers that are in CNNs. But for this, we are going to be focusing on convolutional layers. We also have pooling layers. So to actually give you a reason why we are going to be focusing on convolutional layers, it's because they're actually the basic layers in CNNs. So convolutional layers, just like a layer, we understand what a layer is. So a layer can actually receive input and actually translate it, then pass it on to the next layer. So we have several layers, actually not several, but we have a couple of layers in CNN. So we have convolutional layers, we have pooling layers. There's another layer. There's a code I'll get to show you. So, but since convolutional layers form the basic layers in CNNs, that's why you're going to be diving deep into actually understanding what convolutional layers are all about. So convolutional layers receive input, then transform it and actually pass it to the next layer. So convolutional layers are actually able to detect patterns. So for each convolutional layer, you can actually specify a number of filters. So what I'll say is, for example, you have an image. So CNNs are used in image classification. So if you have an image, then we are going to be analyzing it with CNNs. So with CNN, it's actually able to actually detect those patterns. So for it to actually detect a pattern in an image, so you give it an image and you want to be able to detect patterns. So what it actually does is that it applies a filter. So it applies a filter to the input data to extract features from that image for it to be able to generate patterns that are actually an image. So yeah, that's how convolutional layers work. Mm, I'll give an example deeper in this. So you can think of an image. So for example, we have an image of a tree. Okay, let me say an image where we have a tree, we have a hill, then we have maybe birds. So we want to be able to detect maybe edges in this image. So if we have edges, so we want to be able to use a CNN in CNN, we want to be able to detect edges maybe in this image. So we are going to apply filters. I'll actually get to explain what filters are deeper a bit. So we can be able to actually detect. So we have an image and we're like, we want to see the number of edges or the edges that are in this image. So we can be able to just like so if we have an image, for example, and maybe like I've given like a hill, so we have trees, we have birds, then we are like, we want to be able to detect the edges in this image. So we can be able to use CNNs to be able to give us the number of edges in this image, or maybe so it will actually form patterns. If you have an image where you have a hill, it's not easy for you to actually be able to know how many edges are in this image. So with CNNs, it's able to, when you apply filters to it, it's actually able to detect the edges in this image. So that's actually how interesting it works. So when I talk about filters, so a filter, I'll just say it's a small matrix, not that much of a big matrix, it's like a small matrix in which we determine the rows and the columns. Then from this filter, we are going to apply it, and from there we're actually able to generate a pattern. Uh, I think this is actually not going to be easy to understand without an image. So I have an image from which you'll be able to see how you can apply a filter to an image for you to actually generate a pattern for you to understand how it works. So apart from the convolutional layers, we also have the pooling layers. So the pooling layers are just used to actually enhance each features, or let me say, or even to reduce spatial dimensions. So it's a pooling feature. So they reduce the size of the feature maps while preserving the most important features. So it actually it's used to preserve the most important features. Like for it to be able to detect a feature or a pattern in an image, we actually need it to actually preserve the most important features, which will be able to enable us to generate the pattern. So that's what the pooling layers do. There are two common types of pooling layers. We have the max pooling and the average pooling. So max pooling takes the maximum value from each region of the feature map. Average pooling takes the average value from each region of the feature map. So these are the common types of pooling layers that are actually used to be able to enable when you want to have a pattern, it will actually be able to enable you preserve the most important features, which will make it easier for you. So to enable you have the standard features that you actually need in actually detecting the patterns that you want from an image. So training a CNN. So now how actually a CNN works. Is an image here which it looks actually interesting. So this is actually an example that was used by someone called Jeremy Howard to explain how convolutional layers work. So that's why I was saying convolutional layers are actually the basic, they actually form the foundational layer in CNNs. That's why we are actually going to focus a lot on the convolutional layers. So from this example, we have, this is looks like a number 7, so it's actually a handwritten number 7. So what this example does, so you see this is an example of a filter. So we have only one filter. You can have as many filters as you want to actually be able to get a pattern at the end. So for this example, we only have one filter, but you can have several filters. So you see, it's just a filter is just like a simple matrix. So you determine the rows and the columns. So it is a 3 by 3 matrix. So we can have maybe this and another filter with different values. But for this, we only have one filter. So what this example does, we have this filter. So this filter, so this is so the first part here. So it's 3 by 3. So the pixels in this image, uh, you get the product of the first three. So 3 by 3. So 0, 0, 0, 0, 0, 0, 0. So 3 by 3. The product of this with the filter, then we are forming we have the convolution, so it convolves, so it slides against it. So it slides because you get the product of these three, then you slide and move to the next three, the product, and this is what the result that is actually gotten from the next from this first. Okay, it's just one, so this is what has been convolved. So it's convolutional layers, so it just slides, or you can say it convolves. So that's the product of the three with this matrix or the filter, and it gives this result. So this is actually how it will form the pattern. So it keeps getting the product of these pixels with the filter and actually gives the result here. So this is just with one filter, but we can have more than one filter. So from that example, so we can have, let's say we have 4 filters. So we want to get a pattern of, okay, so we want to detect edges. Then we have -1, we have 1, and we have 0. So -1 is represented by white, then 1, oh, -1 is black, 1 is white, then 0 is gray. Then that's how it goes on, and from filter 1 to filter 4. So with filter 1, so from that example, so just take it as what was happening in this previous example. I hope you guys are moving with me. So this is the first filter. So now we're not having one filter, but we're actually having 4 filters. So for the first the first result, when we convolve it, This is the result we get. Then we move to the second filter, the third filter, and the fourth filter. At the end, we are going to actually see the result of actually the edges that we want to see. So we wanted to detect the edges in this number 7. So we get to see, so let's say we'll take that this bright will represent the edges. So they, so because I think it's the most clear one for us to be able to detect. So we get to see here, uh, we detect the edge. This is it's it's horizontally. So horizontally at the top we get this edge, that is we use the first filter. For the second filter, we get here, so this is vertically, we get that edge. Then for the third filter, we get it here, and for the fourth filter we get it here. So if we wanted to detect edges for each convol we have, we can actually be able to relate from this example. So that's how you can apply a CNN. That's just an example that was used. So a simple example that was used by this guy Jeremy to show how CNNs work. So when you apply a filter, given that CNNs under CNNs for the convolutional layer, you apply filters. So that's how you can apply a filter to an image, and you can apply as many filters as you want. So you just define the number of filters you want for it to actually keep on applying until you actually get that pattern and actually get to see your result. Then we also have this example. So this is actually, you can actually, as we continue, as you go deeper, so you can even get more sophisticated results. Like we get to see here, we got the results for, I think these are dogs, maybe some patterns here. So you can actually be able to have apply as many filters as you want and actually be able to generate the patterns that generate patterns from actually real life images. And once you apply, actually at the end you get patterns. So I think that's just an overview for you to see how convolutional layers are applied for you to be able to generate you get generational patterns. So yeah, uh, so before we move on, I think it was very brief on CNNs. So I hope you guys are actually getting to see how CNNs work. So under CNNs, like I say, we have the convolutional layer. So like, yeah, the way a layer works, a layer receives, transforms, and passes to the next. So you see a convolutional layer will receive when you apply the filter to it. So it actually it will be able to apply the filter to whatever, to the image that it gets, and the result it gets is actually passes it on to the next layer until at the end you get to have a sensible pattern that you can get is generated. Then we have other applications of CNNs. As much as it's mostly used in image analysis, which is actually its common use, it's also used in image classification. Yeah, that is object detection, face recognition, NLP, natural language processing, speech recognition, medical image analysis, financial forecasting, and fraud detection. These are other examples of how CNNs are applied. And based on how a CNN works, how I've shown you guys a CNN can be trained, you'll actually be able to try and see how it can work on face recognition when you actually apply how from the examples that we have. So you can actually just get to try and see how can CNNs be used in face recognition based on how it's used in generating generation of patterns, be able to detect and actually give a result. So we have a sample code for CNN. I'll just go over it. So this is a sample code of a CNN. So import Keras. I think some of you are familiar with what Keras is. It's just a library, and it uses Python. So to those of you who have worked with Python before, it's actually going to be easy for you if you decide to actually dive into learning more on deep learning, machine learning, AI, all that. So if you have a good understanding of Python, you can be able to actually apply it. So we import the MNIST data. So from the number I gave, so like for example, if we have MNIST, these are handwritten digits. They're just data set of handwritten digits. There are so many. There are more than 60,000, I think. So, or yeah, around 60,000 there. So, like for example, if we have numbers, handwritten numbers, for example, we have so many numbers handwritten in one. We have one, we have two, three till 10, and we'd like it to be able to detect and actually group these images. So image classification, how it can work. So we have so many ones, twos, and threes just written randomly, and we'd like them to be able to be classified. The ones to be classified, two classified separately, three, four till 10. We can actually be able to apply CNNs in that. So it imports the MNIST data set. So X train, Y train, that is X is training the data set. Uh, and we have train, and then we have the testing the data set. So you first normalize the data. So normalizing, I believe some of you have heard of normalizing when it comes to maybe databases, and it's not about reducing redundancy. When it comes to machine learning or deep learning, normalization is not about actually reducing redundancy, but it's when we actually do this, when actually dividing it by 255.0, it's actually to ensure consistency in the data set for us to be able to train, to get a scalable input, which is a standard, to give us a standard range for which we can actually use in training the data set. So when we normalize, we're not normalizing to reduce redundancy, but it's for us to get a standard input when training our data set. So you define the model, then you add the convolutional layer. We've gone over convolutional layer. Then you add the pooling layer. And the other layer is the fully connected layer. We've not gone over that, but that's another layer under CNNs. Then you compile the model. Then you can actually get to train your model. So with CNNs, you can train them with it's other supervised learning. So you can give it the data set, then you train it, then at the end it evaluates the model and gives the result. So it prints the result, then it actually prints the accuracy also of the data set that it has been given. So this is just a brief overview of code and CNN. It's not actually fully with everything, but just a sample of how it works once you apply the convolutional layer, pooling layer, and the fully connected layer. Then you compile and train it. Then at the end, after evaluation, it gives you the results. So up to there, I hope you guys are with me on how CNNs actually work. So in conclusion, CNNs are a powerful tool for processing data that has a grid-like structure. When we say grid-like structure, you remember how we had the filters, then we had the number 7, so a grid-like structure. And then CNNs have been used successfully for a variety of tasks, including image classification, object detection, and face recognition. And CNNs can be trained using a supervised learning algorithm. So this is just a summary of CNNs. We've gone under CNNs, we've learned some of the layers in CNNs, and actually we've dived deeper into convolutional layers, which are actually the basis of CNN. And we got to see how CNNs are, how you can train a CNN model into working and understand the filters. So that's where we get actually the grid-like structure. Because from an image, the pixels in an image, from the filter which gives you the matrix, you take the matrix, you get the product, and you slide or you convolve from the image to get a pattern. So you apply you can apply as many filters as you want for you to get a pattern at the end of your image, and yeah, you apply CNNs. Then it has been used for a variety of tasks, and they can be trained using a supervised learning algorithm. When you talk about supervised learning, we have supervised and unsupervised learning. I believe some of those terms are familiar to you. So with supervised learning, you give it labeled data set, and supervised you give it they're not labeled. So yeah, so you can train CNNs with supervised learning algorithm. And that's the end of my presentation. And I look forward to you guys asking questions or actually giving feedback on areas that you'd like to be expanded on more. Yes, Gabriel and Vincent. Okay, so let's begin with Gabriel because I think he raised his hand first.
Thank you. I hope
Come again.
you all confirm.
I'm not getting you clearly.
Can you get me?
Can you type the question?
Okay. I wanted to ask a question
Okay.
concerning NN. My question
I'm
is,
struggling to hear you, so I don't.
that you're
Mhm.
not getting. My question is, can
It's low.
CNN
Mhm.
be? Oh, I'm
Mhm.
very low. Okay, I'm saying, can
Mhm.
CNN
Mhm.
subject adverse role attacks?
Let me just say something. Can CNNs? Can you just type it, please? Um, unless someone has gotten him clearly. As he's typing, Vincent.
Mm, okay, thank you. Yeah, I have been having issues with my sound. I don't know if some of the questions I'm going to ask you already tackled them.
Mhm.
If we've already tackled them, please just tell me tackle them and you just give me a brief on it. On CNN, I will wish to know something concerning back propagation. So I would like you to expound a bit on back propagation on CNN. Again, on pulling layers, there's some part I didn't get. I would wish you talk a bit of it in a presentation. And the first speaker, you sorry, you talked about the techniques in deep learning. There is this technique that I think it's a bigger percentage in deep learning. It's more like 70% of deep learning. It's the transfer learning. I will wish to know something concerning transfer learning and its benefits. And could we please integrate transfer learning with the RNN or the CNN? Thank you so much for the opportunity.
Okay, so
Have you gotten my questions? You've gotten my questions.
Omaima, have you gotten what she has asked for your presentation?
So yes, I get what your questions, and I will answer it. So you firstly ask about back propagation. So back propagation is the neural network training process. It it aims to feeding the error rates back throughout the neural network to make it more accurate. It is in brief, backpropagation is the process involved in training a neural network training a neural network means that you try to make the network learn some features from the data. So backpropagation involves taking the error rate because in every network has an error. There is no, it wouldn't be accurate for 100%. So the backpropagation is the process of taking the error of the forward propagation. The forward propagation, I have explained it, is the process of passing the data from the input layer to the next layer and then the next layer until they attend the output layer. The objective of the back propagation is to minimize the error so that the prediction is more accurate. Did you get this or not yet?
Okay, I'm getting what you're saying, but with the back propagation, how can we use back propagation to tackle the vanishing gradient problem? Sorry, I
How
think
we
somebody
can
didn't
use
get me.
back propagation? Can
Okay,
you
yeah,
repeat?
yeah, yeah.
Can you repeat?
I'm asking how can we use back propagation in tackling vanishing gradient problem?
Mhm. Let me think why.
With the same view, I would wish to know it bigger with the CNN. So when you be bringing out the points, kindly stick with it within the CNN, please.
So the vanishing gradient is caused by the derivative of the activation function used to create the neural network.
Uh-huh.
So during back propagation, a neural network learns by updating its weights and biases to reduce the loss function. In a network with vanishing gradient, the weights cannot be updated, so the network cannot learn. As a result, the performance of the network will decrease. So that's why the simplest solution of the problem is to replace the activation function of the network. For example, instead of a sigmoid function, we can use a ReLU activation function, ReLU or rectified linear units. Did you get the answer or not yet?
Okay, I'm getting it, but you're not pointing out to the CNN, but it's fine. It's fine. I think um getting a point from what you're saying, and it's fine. So the other questions, please.
Okay, thank you.
Monica, I've not been answered on transfer learning. I wish I could get an answer on transfer learning.
I'm passing the questions to Maima for this session.
You asked
Oh, okay,
about
okay.
learning
Yeah.
also. So I will explain to you what is transfer learning. transfer learning is the reuse of a pre-trained model on a new problem. For example, let's say that we have a model that classify spam and harm emails. We will use this algorithm, this model, the model that we built for this task, for the task of the classification of emails. We will use the same model for another similar task. For a task that is that needs a model similar to the model that we have used for the classification of the emails. Did you get it?
Yeah, I got it. But do you think we can integrate, or rather we can deploy the two, CNN, RNN with the transfer learning? Is it possible in your view?
Yes, we can integrate it.
How? How can we integrate? How can we?
CNNs are also, we can build a model using is the process is the same.
Okay.
CNNs we can build a model using CNNs, and transfer learning is a method applied to the model, not to the network. The network will not be modified. We can use, for example, CNN to build a model. We have trained the model, testing it, and it's accurate. That's okay. We can use the same model in a similar task, not
Okay.
in the task meant to be, in another task. That's what we call transfer learning.
Okay.
You understand?
Okay. I get. And thank you. But just the last question.
Okay.
How do we handle domain differences in transfer learning? How do we handle domain differences in transfer learning?
I don't get the question, so you can repeat, please.
My question is,
Yes.
how can we handle domain differences in transfer learning?
Domain differences in transfer learning?
Yeah.
So honestly, I don't have the questions.
Okay, thank you.
The answer for these questions. But,
Okay.
it's
fine.
okay.
It's fine. Thank you so much.
Thank you too.
Okay. Vincent, I hope you feel satisfied with what Omaima has said so far.
Yeah. I'm satisfied. But at least it will be my pleasure. It will be my pleasure getting something from you. Just a last question to you. I think you're okay with that.
Okay.
Okay.
Go ahead.
Okay. On CNN. How does CNN handle varying size data? When we're using data, they are very different. So how does CNN works in that? Because you've talked so well about it and its application, immediately saying that it's on image processing and all that. But how does CNN handle varying data?
Varying data.
I think it will be important for all of us. Varying data.
So varying data. When you say varying data, give me an example of varying data.
I'm saying varying data in that you're saying we are having data from all sources. I mean, we can't use data which is similar.
Mhm.
You get that?
Mhm.
So the data is different in that when you're talking about 5, it's not similar to 4. So how does CNN handle the fact that the data that I'm given is 5 and it's not similar to 5? So how is it handling 5, 4, 1, 0, and the likes?
So how does it get the pattern that this is 5, this is 4, for it to group them?
That's what I'm asking. That's what I'm asking you.
From the example I gave.
Not from the example you gave, just from a general view of CNN and that.
Can I help?
Okay, Gabriel, please help. Gabriel, please help.
I think the inherent architecture that
Okay,
CNN
thank you.
in varying that. And Monica talked about, I think, as in CNN, some dimensional of, for example, if you
The sound is too low, Gabriel. Please, if you can talk higher.
okay, I'm saying that there's inherent architecture of CNN that CNN deploys in handling varying data. For example, pooling layers. Uh, Another one is, I think we have something called translation invariance, whereby CNN are translate invariant, and meaning that they can recognize data patterns and regardless of their location or the input. And I think that property allows CNN to handle variation inputs, different data. I think that is it.
Perfect, perfect. Thank you so much. Thank you.
And remember, my question is in the chat. It has been waiting there for about 20 minutes.
Okay. Thank you so much, Gabriel. So let me go back to your, let me check on your question. So, can CNNs be subject to adversarial attacks? And if so, how can we design and train CNN architecture that are inherently robust and resilient to adversarial attacks, ensuring that input data do not lead to significant or misclassifications? So, Gabriel, is this one question not there too? I think you have two questions here.
Yeah, my question is interconnected. Actually, if my internet was that good, I could have added another one, but I just choose to ask those two that are connected. So it is a yes or no question, and if it is yes, then you need to explain, and if it is no, you need also to explain about that.
Okay. So, Omaima.
Yes, I'm here.
So, Mama is actually more conversant with deep learning and all that relates to AI. I'd say she has expounded on it a lot. So I'm actually going to be passing the questions to her. Yeah, I'm just like a host here, so you guys don't crucify me with questions here. I was just to host and assist in the session, but she's actually more. She has expanded more on AI, machine learning, deep learning. So that's why I'm actually passing the questions to her. So Gabriel is asking if CNNs can be subject to adversarial attacks, and if so, how can we design and train the CNN architecture so that they're inherently robust and resilient to these attacks, ensuring that input data do not lead to to significant misclassifications. Do you think you can give him something to answer that?
Okay.
I can help. I can help in case of I can give out my view.
Okay.
So my first answer on the first question is yes. Yes.
Okay. Gabriel is not with us.
Oh,
He's not even with us.
too bad.
But you can just
Too
answer.
bad. Okay, but it's a yes, and maybe some
It's
of the
being
ways you
recorded,
may,
so
maybe some of the ways that some of the approaches that you can use to enhance the robustness of the CNNs, you might be using some things like adversarial training, defensive distillation, regularization techniques, and the likes. So I think with what he's asking, it's possible, and those are some of the ways to do that. If really you would like to get more about this, I think I can share with you a link on all those things, because they're always somewhere where they can be.
So, Gabriel, I will answer your questions, but I have an answer to the first part. That is, can CNN be subjected to adversarial attacks? That is yes. CNNs are susceptible to adversarial attacks that perturb original samples to four classifiers, such as autonomous vehicles, road sign image classifiers. They are also lacking variance in the classification of symmetric samples because CNNs can classify symmetric samples differently. However, I don't have the answer to your to the second part of the questions. That is, how can we design and train CNN architecture that are inherently robust and resilient to the adversarial attacks? But I think that CNNs, the architecture of CNN is by nature robust and resilient to adversarial attacks. So we don't need to modify the architecture, the real architecture of the CNN, so that it be resilient. It's resilient by nature. That's what I think. I'm not sure about the question, the answer of the second part of the questions, but that's my opinion. I think I hope that you get it, but I will search for it and give you the answer that you need.
okay. So Gabriel, you are not with us, but Vincent answered some part of the question. Emma has actually also added to it. So it's being recorded. You can go, but I don't know if you feel you've been answered.
No, I asked question.
Gabriel, you should feel you've been answered.
I've been answered.
You've been answered. You'll get the recording and go over it.
Thank you.
Okay. Finally, I think Isaiah asked, how did you do your training code? Do you run machine learning code on your personal computer, or how did you learn and practice these concepts? Okay, I know the answer to this. Genuinely, I know it, but I'm going to let one of you answer because I think Omema went over some of the frameworks. But yeah, does someone like to answer Isaiah on that? How do you train your Python code? Or how do you train your model?
Yeah, Jupyter Notebook.
Uh-huh.
Google Colab or Kaggle also. You can train it on local. If you have if you have a computer that is performant, you can train a neural network using VS Code locally. There is no need to use Jupyter Notebook, Google Colab, or Kaggle, but you can use them. I usually use them, and they give me the result that I hope to get.
Isaiah, have you gotten them?
Mm-hmm.
Okay. Mm-hmm. Is there any other question before we finalize? Or comments? Okay. It has been a fun session. Thank you so much, Omaima, for actually organizing this with me and actually bringing it up. So Omaima is she's an engineering student. She's passionate on AI. I see her posting some articles on LinkedIn. You guys can follow her, or I can share with you guys for you to. I think it's on Medium, so you can actually go over them and read them. Or you can even connect with her and get to ask her more and explore with her. Some even reached me in WhatsApp and asked if they can work with her on something. So Maima, I believe it's nice. So to those who will reach out to you and they tell you how they've been referred by me, just know it's because they have interest and they look forward to learning more from you. It has been a fun session, really nice. AI is all interesting, but I'm not an AI person, but it has been fun hosting this and actually getting to learn much for me to be able to present this to you. Thank you so much to those who participated and asked. You're welcome, Celestine. And also someone saying it has been nice. Thank you. Vincent, Gabriel, you guys have made it interesting. Thank you so much for the questions and for sharing with us what you know. I hope you guys have learned something on deep learning. At least you can be able to say a bit, or when you hear someone mentioning CNNs, someone saying deep learning, you actually know what they're talking about. And yeah, this session has been recorded, so I'll actually upload it to YouTube, then share the link with you guys for those in the WhatsApp group from Maseno. I'll also get to share the recording directly with the Omaima. So that's all I have to say for now. Omaima, would you tell us something before we end the session?
Yes, so thank you everyone for your attention. I hope that you enjoy this session and the topic. I hope also that that we answer all your questions about this topic. And if you have some idea or some suggestions to the next sessions, or a topic that you like that we talk about, so you are welcome. We will listen to you, and that's it. Thank you, and good night.
Yeah, thank you so much. Just before I finish up, those of he has already gone. I wanted to tell you guys we have a new MLA saying Maseno, but it's okay. We'll actually get to have a session with him. So thank you and good night.